Hi, everyone. Thanks so much for joining today. We'll just wait a few minutes and see if people file in. Looks like we have a few coming in right now. Thanks all for joining. We'll get started in a few minutes. Cool. Okay. I think we're good to get started. Hi, everyone. Thank you so much for joining us today. I'm Katie Buchheit. I'm a PMM here at Foursquare, working hand in hand with the Unfolded team, and I'll be moderating today's session. I'm so happy to be joined by Nick Rabinowitz. He is our senior staff software engineer at Foursquare. And before we get started, I just wanted to go over some housekeeping items. You'll see we have our question box open for today's session because we will be holding a live Q&A at the end of the presentation with Nick. So throughout the presentation, feel free to drop any questions in there and we'll address them at the end. This session is also being recorded, so you will be given a link in your inbox shortly after this. And yeah, I think that's all for me. And with that, I will pass it off to Nick.
Thanks. Hi, I'm Nick. So very quick intro. I'm a senior staff engineer at Foursquare. Previously, I worked at Unfolded when Unfolded was still an independent startup. I worked previous to that at Uber and ClearStory. I worked at UNOCHA and a bunch of nonprofits and NGOs. I've been working as a software engineer for more years than I like to count at this point, over 20 years. And I've spent most of the recent past in mapping and data visualization. That's what brought me to Unfolded and now to Foursquare, where I work on our Unfolded Studio product and do a ton of great mapping and really interesting data visualization work. I'm also the core maintainer of H3. I'll talk a little bit about what H3 is later in the presentation, but it's a global grid system that you may be familiar with. And I'm an avid geocacher, and I'm now up over 400 finds, so I'm really proud of that, which is not that much unless you're me, and I think it's that much. Quick overview of the agenda. Just in case you aren't familiar with Unfolded at all, I'll do a very quick intro to the Unfolded product. And then I'm going to spend most of the time on some of the new things we've added in the last few months. So we're going to talk about how we've added better data management for your data assets and your maps. Talk about some of the flexible SQL support we've added to the product, and some of the new analytical features which allow for some pretty interesting analyses. And I'll go through a demo of a suitability analysis module that we built. That's really one of my favorite sort of geographic analysis approaches, and I think it'll be fun to go through. And then we'll have Q&A at the end. So please keep questions till the end, but if you have them, please put them in the chat and I'll be happy to answer them. So starting off with a quick intro to Unfolded. Unfolded, as you may be familiar, Unfolded is a web-based application. It's a geospatial visualization and analysis tool, and it allows you to very quickly take in relatively large data sets, drop them right in your browser, explore them, save them, share them with colleagues, make charts and graphs around them. It has a lot of flexibility in the way that we can display and explore geographic data. So for example, we have a variety of layers, including aggregation layers like this grid layer, this clustering layer that does some automatic grouping of your data. Right now, these previous data sets, these are earthquake data sets. So you can quickly take, in this case, 55,000 earthquakes and show them in a variety of different ways to get different insights about them. We also have the support for more complicated kinds of geographic features like points, polygons, lines, trip paths with time associated. We can show a lot of things on a map, and we can allow you to get a lot of information about your data and a lot of detail in the way that you view your data. We can also publish these so that you can share them with either colleagues or with the world. We also have support for some more specific types of data. In this case, we're looking at 3D raster data. So we have pretty good raster tiling support. You can look at a variety of different images, overlay them on the map, and see how that relates to other data sets that you bring on your side. So it's a lot of flexibility and a lot of different types of data support. And we also have some support for time as well. So while the main focus of Unfolded Studio is on maps, we also support other kinds of charts and graphs that can cover your data, including pretty good time sequencing and time-based animation support aligned with the map. So that's something that most other mapping technologies don't necessarily include, but it's a core part of our product. So I wanted to get into some of the new things that we've done in the past few months and give you a sense of where we're going in the product and what you can expect to see. So one of the things that has been a big concern for people using the product and a big piece of user feedback is that they wanted better data management. So they wanted to be able to work with large numbers of data sets, work with large numbers of maps, and just have a better way to manage them in the dashboard portion of the app. So what I was just showing was what we think of the studio portion of the app, the map itself, where you're looking at your data and doing analysis. But there's a whole nother set of the application. There's a whole nother piece of the application, which is what we call the portal or the dashboard, where you can see all the maps that you've made. You can see all of the data sets that you've made. You can share them, act on them, delete them, open them. And this kind of card-based view, which is what we have at present, this was fine, and it was fine to be able to act on one card at a time when you only had 10 maps. But many of our users now have hundreds of maps, and we needed ways to make that more manageable. So we've been putting some new features in to support that. So we now support selecting multiple maps and acting on them. So you can see these buttons at the top. You can copy multiple maps, you can share multiple maps or delete them. We also have tagging, and you can add tags to your maps, to your data sets, to other assets, and then use those to search. So this is an example of a multi-selection action. Here we are sharing multiple maps with people in our organization. So if you're an enterprise user, you can have other people in your team, and you can share things with them and make sure that they can benefit from your work and your analysis. On the dataset page, where you tend to have even more data sets than maps in general, we have a whole additional set of tabular view support, which also allows multi-select. And it allows things like select all, select none. You can do filtering, so you can filter for different types of data sets. You can filter by data sets that are used in maps or data sets that aren't used in maps. This is a really good way to clean out some of the data sets that you don't really care about, or to look at the data sets that are used more frequently. You can do this kind of multi-select. You can see everything you've selected. And if you were, for example, cleaning out some of the data sets you no longer needed, you can do a multiple delete operation. So it's all kind of basic stuff, but it's stuff that really helps to be able to manage these assets within the system. And that's something that's really important to us, because we want you to put a bunch of useful things in there and then be able to find them quickly and use them in maps as quickly as you want to. I also wanted to mention that we now have a new section of the dashboard just for queries, and I'll get a little bit more into SQL support in our next section. But we have a set of data connectors that can connect to your own databases, and now queries are a top level concern for the dashboard as well. You can see the queries that you've made, and you can see the specific queries, the SQL that you actually put in there, so you can get a good sense of what's in each query and where you might reuse it. That's a pretty good segue to this section on flexible SQL support. So one of the major requirements for especially for enterprise users, is to be able to connect to different kinds of SQL databases or backend databases. We currently support BigQuery, Snowflake, Postgres, Athena, and recently we added PrestoDB. We're continuing to add to this list as we go. And this is a really important feature for us because our main thing is to allow you to get as much of your data into the maps as easily as possible. And so being able to connect directly to your database makes that faster and more flexible. And it also means that you don't have to worry about storing your data in our cloud-based system. There's no security implication because the data never leaves your browser. It comes from your database into your browser. You can look at it, analyze it. When your database updates, your map updates, and we don't have to worry about storing or keeping that data updated within our system because it still lives in your system. So I'll get into a few of the new features we have here. We now have different connectors that you can add directly from the map. So when you go to add data to your map, you can choose the different connections you have to different backend databases. We have a fairly flexible, query-based interface. You can see the schema on the left. You can see what's in the database that you've connected to. We have autocomplete for the things within your schema, and you can make the kinds of queries that you want to make directly to your database. So you're not using our proprietary language, you're using your own SQL the way you're used to. The results come back fairly quickly. This was 65,000 rows in 5 seconds. This is a database of trees in San Francisco streets. And you can see them almost immediately on the map. Get them very quickly from the database right into a place where you can visualize them. One of the things that we've been adding recently is this idea of adding query parameters. So you can see here it says wrap values in these curly braces to define query parameters. You can add, when you update your query, you can see that updated query right away on the map. And if you want to make this flexible for your users or for yourself in some cases, you can wrap parts of your query in these curly braces, and that makes them a query parameter. And a query parameter is something that you can more easily update without having to go and edit the SQL every time. So you can go and edit the SQL if you want to, but when you make something a query parameter, it'll actually show up over here in the layer side, and you or another user who's looking at the map can change these parameters and immediately see the result of that reflected on the map. So here we've changed from oak to eucalyptus. Now we're looking at all the eucalyptus trees in San Francisco. We're going to expand this even more to make a more flexible UI. And what I'm really excited about here is that this starts to get to the point where you can basically build your own mini application right within our product. You can build, a way of connecting to your database and allowing the user to make some UI choices that allow them to quickly see different slices of your data, and that's one less application you have to build custom in your own company or organization. It makes it very easy to build out these flexible interfaces for your customers as well as for yourself. One other thing I want to highlight here, we now have query bookmarking. So if you have a query that you like and you want to reuse, you can name it, you can give it a description, or you can just use the SQL as the description. And now it shows up in your list of bookmark queries. When you go to add it to a map, we now have this new bookmark, street trees by species. And instead of going and typing in the SQL, now you can just find this in your bookmark queries, add it right to the map, and you'll get it there. That brings me to some of the analytical features that we wanted to talk about. It's great to get data into the map. It's great to view that data and visualize it. But at the end of the day, what we want to do is understand more about the data. We want to derive insights about the data and be able to use the visualization features and the exploration features of the interface to be able to draw conclusions or make business decisions or come up with insights that you weren't familiar with before. So we've tried to iteratively add more and more analytical functions to the application. There's always a balance here to not overwhelm the user with different pieces. But what I like to think is that we're widening the space of analytical capabilities. Every time we add a new feature, there's a new set of analyses that you can do with our application and a new set of questions you can answer that you couldn't answer easily before. So I'm pretty excited about this. This is really where a lot of my passion lies. I mean, I like I like the visualization, I like building out maps, but I also really like using data to answer questions. That's where I think the real value in a product like this comes from. So some of the things we've added in recent months to support this, we've added improved charting capabilities. So we started off with just the timeline chart. Now we have a lot more. We've added a variety of geometry functions that get us increasingly close to a real GIS tool like Esri's suite. We're never going to quite be there. That's not our sweet spot as a product. We don't expect to be an expert tool for expert users all the time, but we want to be able to cover many of the use cases that you might otherwise have to turn to a really heavyweight, difficult tool like Esri for. And finally, we've added we have a growing list of what I think of as canned analyses, pre-built analytical flows that perform one specific type of analysis that you can apply to your own data and get answers very quickly for a particular kind of workflow. And so I'll go through a demo of suitability analysis, the module we build out for one particular kind of analysis, and I'll walk you through how that actually works in the app. So just to start off, I want to highlight some of the new charts and chart capabilities we have here. We now have this ability to add a chart panel and to add multiple charts to that. So you can take different types of data about your data sets that you're seeing on the map. You can do, binned histograms. You can do time series. You can do just, basic calculations, basic aggregations like how many rows are in my data set, or what's the sum of all their ages, or something like that. And each of these charts has a fairly detailed set of possible options that you can choose from. You might be familiar with this kind of stuff if you've ever used a product like Tableau or any other charting product. We give you many of the same kinds of capabilities to look at your data in different ways. So not only can you, choose an X and Y axis, but you can choose different kinds of aggregations. You have control over formatting. You can choose, grouping so that you can have stacked bar charts or grouped line charts, for example. You have all the same color control that you have on the map itself. So you can choose different color schemes, both categorical and range-based. So we're really trying to build out a pretty powerful, call it a mini charting application next to the map that you can use to see other things that your map isn't going to be the best for. As a quick aside, as much as I love maps, they're not always going to be the greatest thing to answer certain types of questions, even if your data is geographical. Sometimes you really need a timeline. Sometimes you really need a bar chart. Bar charts are a great way to answer questions like, what's the most common tree on San Francisco streets? I'm not going to really be able to answer that question easily by looking at the map, because that requires me to effectively count every dot. In a chart, you can see that really quickly, and you can see, oh, the London plane tree is the most common tree by far on San Francisco streets. So charts are a great addition to a map. Even if your data is primarily geographical, being able to also chart it gives you this extra layer of information that I think can be really valuable. Getting into some of the geographic, what I think of as geometric capabilities that we've added. We are growing out a list of things that you can do with your geographic data to do different kinds of analyses and to do different kinds of geometry work with them. So one example of this that I wanted to show was this buffer function that we now offer. So some of the things we offer through the UI, some we offer through our dedicated column metrics, which are, you can create these little expressions that define new columns and give you new data derived from your current data. So in this case, we are taking this data set of street trees, which has latitude and longitude, and we're going to buffer that latitude and longitude so that we can create little buffered rings around every street tree. You might want to ask, why would I want to do that? Well, there are lots of different types of analyses where buffering is actually really useful. One of the ones that I wanted to highlight here is if you want to align, for example, street trees with streets. Streets are generally come in as lines. Trees are probably going to come in as points. And if you ever tried to do a spatial join between lines and points, it's going to be very difficult because the lines would have to be exactly congruent with the points. You'd have to have the points exactly on every line in order to do that in a proper join. So instead, what we can do with buffering is we can say, I want to find all the trees within, some distance of every line. And if, in this case, what I want to do is I want to look at this grid of streets and I want to find the segments that have the most trees or the fewest trees. And to do that, being able to buffer the trees, create this polygon that I can then join much more easily with my lines through a simple intersection operation, makes it a much more feasible thing to do. I can do a spatial join. I don't think I do walk through a little bit through the, nope, I didn't include the spatial join interface, but the spatial join interface is pretty simple. It gives you the option to, join one set of geometry with another. You can choose different kinds of joins like intersection, and you can choose the kinds of aggregation. So in this case, I've taken every tree and I've summed up the number of trees, the number of tree IDs that are related with a given line segment. And I've done this join, so now I can see all these line segments within San Francisco, and I can see how many trees from this other data set are available on each. And this is really getting to what we find to be one of the most valuable parts of our application, is the ability to bring in these disparate data sets, these things that don't necessarily relate to each other easily, don't necessarily have a common join key a priori, and make it easy to combine them and do a combined analysis. This brings me to the demo that I wanted to do, which is about suitability analysis. Suitability analysis is really one of my favorite geographic analyses. One of the reasons I really like it is because I'm not a data scientist, and I still find it really easy to follow, easy to understand. So suitability analysis is a way of bringing in a wide variety of data. You put it all in one common unit of analysis, you join it all together, and then you can weigh the different features that you're interested in and get an end score that combines them all. Why would you want to do this? Well, one of the most common options is site selection. So let's say that I'm looking for a place in San Francisco. I always think of this as an individual. I tend to think of this as, I'm apartment hunting, but as a business, you might be trying to find a new spot for a store or a kiosk or an advertisement. And you want to find what are the richest spots within this area for me to look at. So I'm going to start by taking this same data set of street trees that I had been playing with in the previous examples. I've got all the street trees in San Francisco. And I guess I'll take this as the apartment example because it's the one dear to my heart. And I love living on a tree-lined street. So one of the things I might care about is I might want to care about how many trees are in the area that I'm looking at in the city. So it's difficult to do this if you start off, well, it's difficult to do this with points, because what you really want is a smooth surface of value, a smooth surface of where we get the best value given the metrics that we're bringing in. And so the first thing I'm going to do is I'm going to convert these trees as points to hexagon buckets. I may have mentioned that I work on H3. H3 is a hexagon-based grid system, and what it allows you to do is to take data that might not be in a common unit of analysis, take geographic data, and align it into these hexagon-shaped cells so that you can easily see a grid of data rather than individual points or lines or polygons. So I'm going to take the longitude, the latitude of every tree. I'm going to choose the resolution for the grid, which in this case is Res 9, which is a little bit bigger than a city block. I will create the column. And now I have this H3 column. To give you a sense of what this looks like, trees H3 res 9. I can quickly show you the H3 layer. This is going to be some of the trees and how they've laid out in these hexagon-shaped buckets. Now, right now, I still have one hexagon for every tree. And what I want to do here is I actually want to group and have them bucketed and aggregated. So to do that, I'm going to do a group by operation. I don't really care about anything but the count of trees. So I'm just going to take the tree count here and I'll run that. Now you see I'm making a new data set with the H3 bucket and the count of trees. I'll confirm that. And when right now this isn't colored, but if I look at the count of trees, now we have a sort of proper heat map of trees in San Francisco. Now, obviously, if you're trying to choose an apartment in San Francisco, trees are not going to be the only thing you care about. Might be an important thing, but there are going to be many other things that you actually want to consider. So I'm just going to bring in a few other data sets and join them to my existing data set so that we can do a more multi-metric suitability analysis. I'm going to pull these from the data catalog, and which data sets you pick, what additional things you want to bring together really depends on the different parameters you care about when you're making a decision. One thing I want to show, partly is this is a new data set, and I think it's really interesting, is this US buildings data set that we added. This is a hex tile data set, which means it's a multi-resolution, very large scale data set that's been pre-aggregated to these H3 hexagon cells. This is a proprietary technology that we have within our application that helps us to work with very large data sets. And it's a data set of US building footprints. And what that means, as we zoom in, you can get these really fine-grained views of where buildings are. And it's a really nice proxy for urban density. You can say where there are more buildings, that's going to be a denser area. When there are fewer buildings, that's going to be maybe more of a suburban or a park-like area. So this is the kind of thing that might feed into this analysis that I want to do. I'm going to join my existing group by data set. I'm going to join it with this street map building. So I pick my H3 index field. I'm pulling in these columns. I don't really care about some of these, but I care about the building count. I'm going to run that. Now I have a joined data set with the building count and the tree ID. Confirm that. And as I go, practically every step here, I end up making a new data set. So I do a little bit of hiding of the old data sets as I go, but I think that this gives you a nice checkpoint for every place that you've been in your data analysis. One other piece of data I wanted to bring in here, maybe a little bit arbitrary, but if I'm looking for an apartment, maybe I want to be around people my own age. I probably shouldn't say what my own age is, but let's just say that I'm in a particular range of the census category. And so maybe I want population and age information to be part of my analysis as well. So I bring in this data set of age from the census data set. Right now, I think we're just looking at total population, but it also has different columns for different specific age categories. So, we can look at where there are middle-aged people, where there are slightly older people, and you'll get different distributions across the area. Again, this is a hex tile data set, so what's great about this is it covers the entire United States. It's not just San Francisco, but anywhere that you're looking at in the United States, you can pull this data in and add it to your analysis. So right now, I have a fairly specific area that I'm interested in. But if I was interested in doing the same analysis somewhere else in the country, I could pull in another section of this data set. So again, what I'm going to do is I'm going to join my current working data set with this age data set. I'm going to pick the H3 index field again. I'll run that. And you can see now I have the tree count, I have the building count, and I have all this data from the population data set as well. go back to my layers. I'll hide a few things to keep it a little bit simple. So I'm almost to the point where I can start doing the suitability analysis, because the first step of doing a suitability analysis is to bring together all of the data that you actually want to look at. One thing I thought I would do first here is, when you look at, if I wanted to look at, where there are more young people, where there are more old people, it's one thing to just look at the absolute count, but that's actually going to be very closely correlated with the total population. So I thought it'd be interesting to, let's rename this to be our base data set. They get these names that go join, 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 and that can be useful to figure out how many things have been joined in. But when I actually want to work with it, calling it base data is going to be a lot more interesting, I think. So I'm going to create a new column here, and let's just do a ratio of, I suppose I'm middle-aged, so we'll just say middle-aged folks. People of my age group. And I'm going to pull that in here, and I'm going to divide that by the total population, and now I have the ratio of people in that age group. So that's going to give me a little bit better sense of the distribution of people in that group. So I think I'm ready now to do my suitability analysis. And our analysis modules are over here. We only have a couple now, but we're building these out. So I select suitability analysis, and this basically gives us a custom built UI for doing what would otherwise be a slightly complicated set of calculations in the application. I'm going to select, let's make sure I have the right layer here. So the layer that I'm looking at now, let's call this base data. I think it's going to clarify things a bit. I'm going to select my base data layer, and it gives me all the columns that are in this data set with little sliders that I can use to say basically how important they are to me. So what's going to happen is it's going to normalize all of these different columns between 0 and 1, and then it's going to apply whatever weight I'm selecting here. So I don't really care about a lot of these. Let's say I care about the building count. I might care about the population. I don't really care about most of the age categories, but I do want my ratio. And so now I have these specific metrics that I've decided are part of my analysis. I'm going to give myself a few more colors. We always default to 6, but I always like it a little bit better when we have some more colors in the output range. And I'm going to run the analysis. And at first, what that's going to do is I haven't set any weights, so it's going to weight these all equally and say these are the areas where the combined value of all of these is greatest. So you can see I'm starting to divide up the city into areas of the most valuable real estate for my own set of use cases. As it happens, I want to apply different weights here. So if I start applying weights, I say, well, actually, building count, maybe I don't want it to be quite as important. Like dense is nice, but it's not as important to me. Population isn't super important to me. So I'm going to bring that down. Whereas I really care, I care a lot about the age groups, and I care a little bit less about the trees. Now I've got a slightly more nuanced view, and you can see that the map is updating in real time as I go. Now, one of the things that I often do here is, by default, all these sliders go from 0 to 1 for the weights. But if we go down 1, now we have sliders from -1 to 1, and that means I can downweight things. So it turns out maybe I don't want to live in a super dense area. I want to live where there are a little bit fewer buildings. I can give it a negative weight, and that's going to downweight the building count. So it essentially says we're going to count building count against the score, even though we're still counting some of these other ones, higher up. Maybe I don't want to live in a densely populated part of the city. So now I have two things that have been downweighted, two things that have been weighted up. I confirm, and now I have a new data set and a new layer. So this new data set is my suitability result, and I've got a new layer for my suitability result, and I can explore where I found the best places. One of the best ways to do that is simply to start filtering down. I can filter down on my suitability result based data. I'll select this score field, which is the calculated field that we're showing in the layer. This is the overall cumulative result of all the weights and all the metrics that I brought in, and I want to find some of the places that are best. And I start filtering down, and it looks like there's some places here that would be really interesting to look at. Some in Bayview, some north of the Panhandle, and those might be places that I could start looking at. The Beauce Triangle, where, as it turned out, once upon a time I actually lived, comes up as a nice, possible place for this analysis. And this helps to narrow down areas of the city that are going to be most valuable for my use case. So hopefully that gave you a pretty good sense of what suitability analysis looks like. The really interesting part about it is that you can bring in whatever data you want. It's not just the data that we offer within the app, that we offer a lot of useful data like census data that can be valuable in a lot of different analyses, but you can also bring in your own data. You can convert that data usually to H3 or to a common geographic area like zip codes or counties, and then you can do the same kind of analysis. So I frequently think about doing this analysis in in a narrow context like a city, but you could do the same thing for the entire country if you wanted, if you have the data to cover it. So it gives you this really flexible way of finding areas of great interest for a particular use case. That completes most of my content for this webinar. I hope you found it really interesting. I'll leave this slide up, but if you have any questions, now would be a great time to ask them. And I hope you enjoyed the talk.
Thanks so much, Nick. Yeah, if you have any questions, feel free to drop them in the chat now. A few did come through throughout, so I'm probably going to start there. Nick, we have a few questions about suitability analysis, and you went really deep into that, which is very helpful. Can you speak a little bit about the methodology behind the color scales that are used on the analysis module?
Yeah, so I mean, the color scales that are used are all the same. I'll actually go back into the demo section of this. The color scales that we're using here are all the same color scales that we use for most of our layers. So we have a lot of flexibility in the kind of color scales that we can use. I'll actually take the filter out because it makes it a little bit easier to see. We have a variety of color scales. Some of these are things we've designed for the app. Many of them are color scales that come out of visualization research. So there's been a lot of, I won't go into it in depth, but there's been a lot of color theory research about what scales allow you to easily differentiate between color classes. Some of them come out of color brewers, some of them come out of other kinds of visualization research. And when we find really good color scales, we tend to add them to the app. So there's the color range itself, which is the set of colors that you're defining. And we're usually defining a discrete set of colors. So you're identifying, in this case, 12 color classes. And each one is going to give you a slightly different feel and may also give you a more or less ability to differentiate between the different classes of color in your data. And then the question of how we break them up, there are a few different ways that we can do this. We can do a quantized scale, which is just a pure range scale. We can do a quantile scale, which breaks it up so that there are even numbers of rows in every section of your color range. And we recently, well, within the last 8 or 9 months, we offered Jenks natural breaks, which is another way of breaking up the color space to highlight some of the key variations in your data. And we also support custom breaks. So if you want to go in and you want to edit your colors very carefully, you can change the color scale in the way that makes sense for you. And this is great, particularly if you have a color scale where the bucketing matters because it aligns with something outside of the application. It aligns with your own personal categorization scheme or something like that. So there's a lot of different ways we can use color. The suitability analysis, we chose a default color scale, but you can also apply whatever color scale you prefer to the analysis. Frequently having a divergent color scale, especially if you have some things that are down-weighted, is a good idea. So some of these color scales just go from, basically nothing to best. A divergent color scale like this one goes from one extreme to another extreme. So if you want to see which things are bad as well as which things are good, a divergent color scale can help with that. That was probably a much longer answer than you were
That was
anticipating
great.
that question, but I have a lot to say about color.
Appreciate the details. You kind of touched a little bit on best practices for color scales. Do you have any, I guess, best practices for running a suitability analysis in general that you would like to share?
That's a good question. I mean, I think that figuring out ahead of time what data you want is going to be really useful. You don't necessarily have to have it all a priori, like we can keep on running new and new analyses and you know, do a lot of iteration, which I think is one of the valuable pieces of the tool, is that it allows you to iterate pretty quickly. So doing some amount of iteration, I usually I usually am sort of going back and forth, and let's put it this way: I'm usually looking at the map that I get out of the suitability analysis, and if I have some prior information about that map, one of the great things about mapping in general is you know things about the geographic area you're looking at. There's data in your head that's not on the map. So you can look at a different neighborhood of San Francisco and you can say, I know something about that neighborhood, and I know that, a priori, I know that it's going to be more or less valuable, or I have a hunch that's going to be more or less valuable for my use case. And so I usually do some like proofing of the results that way as I'm adjusting the weights and say, oh, these weights are actually giving me what look like reasonable results in the places I'm familiar with. And that gives me a hint that they might be giving me reasonable results in other places that I hadn't really thought about. In this Sunset corridor over here, I wouldn't have necessarily thought about that, but looks like it probably has a lot of trees and might be a really interesting place to look at. So that's one thing, is just to sort of gut check as you change the weights. More data is usually better, but you want to be careful that you're not bringing in multiple pieces of data that are essentially duplicates. So if I have the ratio of young people, but I also have a separate, number of young people, those are going to duplicate themselves on some level. If I have number of young people, but I also have total population, that's going to give a kind of double weight to population in general, I would say. So those are some things that I tend to do. But the key part is just coming up with the data that's really going to help you and answer your question. What are the key things you care about in your use case? And how can you put those together in a way that can give you this more gestalt picture of your data set? One other thing I would note here, and I've done this in other contexts, we don't offer it exactly within the application, but it's worth thinking about, is if you're not sure what weights to pick, one way to do this is to take existing points that you might know about and look at what weights make sense for them. Like, what are their weights? Do they have more of one thing or more or less of another metric? And use those to help you to figure out what the weights might be. So you can do that sort of spot by spot, or you can do it, separately in a notebook or something like that. You can derive the weights in some cases from known good places. That's a more involved approach to this, but I think it can be really useful in some use cases to be able to derive the weights.
That's a great roundup. I'm sure you have so much more to share. So we should do a whole webinar on that. I did have a question just come in, kind of a more general question. What is the most common use of Unfolded?
That's a really good question. And one that from a customer metric standpoint, I wish I could answer with definitive knowledge. I mean, the good and the bad thing I would say about Unfolded is it is a general purpose tool. It solves many different geographic kinds of problems and handles many different geographic types of data. So we have customers doing things as varied as looking at specific trips for specific vehicles over time versus doing global analyses of things like Wi-Fi speed in one case, a global analysis of tree cover in another case. So we definitely have some people looking at things like climate change or other sort of geographic data sets that cover the entire globe. And I think we do pretty well in both. We do pretty well in the micro sense, where you're looking at one city and doing a fairly local analysis, and we do pretty well in the global sense, and we have pretty good views of the entire world and pretty good data sets that can cover the entire world. I would say that I think we shine especially in exploratory analysis. So when you don't necessarily know all the things you're looking for, you don't necessarily know the answers to your question, and you want to use our data set, our data in some cases, but also our application to really investigate and look for things that you didn't know before. That kind of exploratory data analysis is something that we're quite good at, and I think a lot of people use us for that purpose.
Great, thanks for that. So I know we are very close to time, but I want to leave the audience with 2 links. I'll drop them in the chat. If you haven't tried out Unfolded before, feel free to check it out for yourself using the link I just dropped. And then if you have any more questions for Nick and the team, we welcome you to our community. We're on Slack. Feel free to drop any questions in there. And thank you all for joining again. It's been a pleasure.
Thanks so much.
Nick. Bye, everyone.